would like to talk about algas and which potential basing on article published in 2022 in Biomass, the effects of innovative processing methods of microalgae cell wall prospects towards digestibility of protein-rich biomass. The work is made by University of Minho in Portugal under leadership of Professor Ricardo Pereira, and how are microalgae aspects and how can be used, how can be given. The microalgae are small organism, plant organism which possess photosynthetic efficiency. First, the application is due to leaving carbon dioxide reduction, and in this case, some microalgae and algae can make biophotolysis, so split some water into hydrogen, not very much, but it can be used. And existence of rigid cell wall is for most microalgae species and is some obstacle to higher bioavailability for protein, which are in plant and can be used as pathway. Therefore, we need to find better methods, some enzymes to cut this cell to get for efficiently to lipids and lipids as a toxin, some polymer that can be used for vaccine and biofuels production. This the review intends to fulfill the gap by addressing the major impacts of innovative, sustainable processing of microalgae biomass, giving particular attention to drying operations and cellular disruption methods based on electric field applications, such as pulsed electric fields and moderate electric fields, using microalgae biomass as food supplements, and its full potential depends on its protein digestibility patterns and subsequently the bioaccessibility and bioavailability. The importance of using in vitro gastrointestinal systems to understand the impact of innovative downstream processing of microalgae biomass will be addressed. And what are historically they began the first application existed for billion years. First application for food were made by Aztecs and Indian tribes, and then was as a food additives was in minimal cases up to 1950s, where in Japan they designed that can make some other jellies from these microalgae, which can sustainable and replace high expensive for Japan jellies, and this was and for food, and this was useful in food products in Japan, Taiwan, and Mexico, were mostly chlorella and arthrospira. Now is growing with big to biotechnological due to, because agar plates, for example, are supposed considered as one option of nutrients for starting bacteria, feeding, breeding, agricultural cultivation of for medicinal purposes and drugs. But also they produce lipids inside that can be by extraction to fuels as biofuel, biobutanol, bioesters, which can be ethyl ethyl esters. So they're coming by extraction by Soxted extraction, microwave extraction, but mostly by Soxted extraction can be obtained. But the other compounds between riches and reserve substance are carbohydrates are useful for animal feed and can be used for polylactate, polyalkoxybutyrate, and some other polymers, depending how we transform this waste, or by simply also extraction, or by pyrolysis or biochar and produce some more. They can be used also as pigments and source of vitamins and minerals. The promising source are essential amino acids, such as used for food crops such as milk, soybean, or meat, and recognized by Food and Drug Administration as generally recognized as safe. And this case is the chloramaldinoponols and chlorella vulgaris and guarana crassus. This species were used recognitions, while European Union accept for human suspension more, also chlorella vulgaris and Arthropospira plantensis and pyranoids, and are classified as non-novel food and between crude proteins that is suitable for low people or of human with nutrition troubles, and to people that don't want dry biomass, that, for example, vegetarians, replacement of meat, and other pigments as astaxanthin, which is suitable for pharmaceutical purposes, and ameliorate microalgae species is being characterized, and cultivation are being optimized toward the production and feed ingredients. Currently, one of the major challenges of microalgae are better elucidation and digestion, and more better understanding how some nutrients work or function in human health. Is proteins can be used protein source. That's why interest of vegetarian diets, and this is green and carbon dioxide with carbon dioxide capture, so they can be more or less stable. So, for example, they can be produced even in roofs, for example, of some skyscrapers. Already is made in some conditions that skyscrapers can grow. For example, in New York and in Korea, Sydney, some gardens on skyscrapers on the roof of building can be even, and if so little basin in the roof, they can be also and produce both proteins and with loss areas and making greener area which make less more carbon dioxide and more efficient because green is some color that would make more light and therefore reduce the myoscopia in some people, especially like Singapore and or high skyscrapers area like Hong Kong. So this can be used very common application. So these are other sources. Protein sources are macroalgae are bigger than macroalgae 3 times, but still lower than, for example, crickets. Crickets seems to be very important, could be conventional source of proteins, as well as grasshoppers, even 75%. So even better than that meat, which are 40%, egg and soy. This is the case. And so you see that can be very high. Microalgae similarly to conventional, but still lower than insects. So several cases are, but you see, we look in India is growing popular commonness. So research, high-scale research about consumption of grasshopper and crickets and some even cockroach because due to high level of proteins. For example, another is nanochlorosis with present hemicellulose of 80% and is well known for high lipid contents. That is for biofuel production. Of course, there is also Yarovia, which are much better. Sedimentus stamus is good for glucosamine protein. Athospira is good for gram-negative cell wall components of liposuccinate, some of present weight, and no cellulose interval. So some think that only hemicellulose use can be very good for only hemicellulose source and see how it can be used for biopolymers or biofuels. So these are in research found. So relationship between products, harvesting should be divided, how to make harvesting with low energy, how to produce, give them the proper light because they need some the problem of this that can be insufficient light or there can have some extra light in more darker areas or not. And these are somehow so technique for drying and solar, some degradation during slow drying, overheating of microalgae can occur, so we need to avoid. In case of microwave drying, so is still some more degradation of biomass that it should, some big losses of material are one of the trouble. Yellow physicalization, electrohydrodynamic, still similar like microwave, but concern much more cost. But in case of electrohydrodynamic, needs application high voltage difference, so high energy consumption, and present and heat generation in system. And cell destruction methods are used and microwave is as protein-dependent nutrition due to heat. It causes increased pressure inside. That circulation with cell wall is caused by evaporation of the cell water. So there are mechanical, not mechanical, sneezes, non-mechanical acid, osmotic shocks. There are several where mechanics are electro-based, microwave homogenization, and this cell integrity, bioaccessibility, in case of is adaptive of rules processing. So in case of enzyme, in case of electro of mechanical is good extraction of biocompounds, but it's harder process control in bigger degradation of biocompounds. So this is the comparison. And for these, I think it's all one of the all. So yes, are mass good for gastrointestinal digestion, good for application for biofuel and reducing of greenhouse effect. They are most available and most important things. Thank you very much for listening.